The first device we're going to look at is a circuit breaker. So it prevents your devices from being heated up or from being destroyed by a large amount of current. So for example, you have your device, a television or any other device over here, and this is your whole circuit breaker. Now, if you have a current that is greater than 10 amperes flowing through the circuit, your TV will get destroyed. How do you prevent that? You have a circuit breaker. Now, what happens when there's a current greater than 10 amperes? First, let's discuss what happens when you have a current of 10 amperes or lesser than that. So, your solenoid gets magnetized. There is a magnetic field around the solenoid, but it is not strong enough to attract this piece of iron. And when you have a current of, for example, 11 amperes flowing through the circuit, your solenoid gets magnetized, and that field is so strong that it can attract this iron lever towards itself. When the iron lever is attracted, these contacts break. There's a space between these contacts, and so your circuit breaks, no current flows through it, no current reaches the television, and so this current of 11 amperes does not reach your device, and your device is saved from being burnt up or destroyed. So this is how your circuit breaker saves your devices. And why is it used? Why aren't fuses used, or why is this preferred over fuses? Because it has this reset button. You can just push it, the contact will come back to its own place, and so you can use that circuit breaker again. It's reusable and very convenient. Then you have loudspeakers. So in loudspeakers, you have alternating current, which means that current flows in two different directions. So you have two cases, one in which your current is flowing like this. Now, since it's alternating current, so current will also flow like this. So since current flows in two different directions, the north poles are going to be different. Now, if I bring magnets towards my solenoid, for example, I bring the north poles of magnets towards my solenoid, and so using the right hand rule we can find out the north poles of this electromagnet. So how will we do that? We'll use the right hand rule. We'll curl our fingers in the direction of current. Over here the north pole is here, and over here the north pole is here. So we have the south here and the south here. In this case, we know that attraction will occur. So your solenoid with the loudspeaker with the paper cone attached over here, all of it moves towards the magnet. Attraction occurs. Over here, there are unlike poles, repulsion occurs. So this keeps on happening. Since you have alternating currents, the direction keeps changing, and so it keeps attracting and repelling, attracting and repelling, attracting and repelling. This happens at a very high speed, for example, at a frequency of 50 hertz. And so when that happens, what happens is that either your particles are pushed close to each other or they're pushed away from each other. This paper cone keeps vibrating, and so compressions and rarefactions form, which means it's a longitudinal wave, and hence sound is produced. Over here in this diagram, you can see that this solenoid is attracted or repelled to and from the magnet, and so your paper cone moves and it vibrates, and so sound is produced. Then we have a relay over here. So a relay is basically a switch that is used to connect your main electrical circuit to your device in cases in which you cannot directly connect them to each other. So over here, I have my first circuit in which I have a solenoid, a switch, and direct current batteries. So when I close the switch, I have a complete circuit. What happens? Conventional current flows in this direction. This becomes magnetized. Using the right hand grip rule, I can say that my north is on my left, and so this this electromagnet attracts this iron rocker arm, and the position of this iron rocker arm now becomes as such. When that happens, these contacts are pushed towards each other, as now this iron rocker arm moved like this. It moved in an anti-clockwise direction and it pushed the contacts, and so this gap between them is no longer there. When they're stuck to each other, when they are now in contact. So your circuit completes, and so current flows and your device switches on or whatever. Your motor, your device, whatever you have connected in circuit 2, that turns on. So when you turn on this current, then current flows throughout both of the circuits. But when you turn off this current, when the switch is open, so then no current flows. So this is kind of a large switch that is connecting two circuits. And if you turn on current of one switch, the other circuit also closes. And so current also flows throughout the second circuit.